So here it is. The difference in the fraction of successes in n trials differs from the probability of success by less than any positive tolerance E. That goes to 100% as the number of trials increases. Okay? But what does this mean about drawing tickets out of a box? Okay, so let's suppose I have 5 tickets in a box, and I draw a ticket from the box, one ticket from the box with replacement over and over and over and over again. Okay? The law of large numbers says I'm going to get the ticket. What's the probability that I get the ticket labeled A? In each draw, it's 1/5, right? So probability that I get the ticket right, it's 20% in each draw. Okay? So the law of large numbers says that as I draw from the box more and more and more and more times, the fraction of the time that I get the ticket labeled A is increasingly likely to be close, arbitrarily close to 1/5. I won't get it exactly 1/5 of the time, but the more times I draw, the greater the probability is that it's going to be arbitrarily close to 1/5. So if I drew from this box a zillion times, I would see the ticket labeled A about 20% of the time. I would see the ticket labeled B about 20% of the time. I would see the ticket labeled C about 20% of the time, et cetera. Yes? Okay. With high probability, right? It's not guaranteed to see it exactly 20% of the time, but I'm very likely to see it nearly 20% of the time. Okay, so what would happen if I added up the numbers on all the tickets that I saw in a very, very, very large number of draws from the box and took the average? If I take all those results, I draw from the box n times where n is really, really big, and I average what I see in those zillion draws from the box. Well, I would have some random list of labels, like I might get A, E, D, D, B, C, B, etc. So there's going to be some string of labels that I get as I draw from this thing repeatedly. And they're going to be a random number of each label in a random order, so forth and so on. But if I go through and I have n of these in all, then of those n, with high probability, the number of A's is going to be about n divided by 5, right? And the number of B's is going to be about n divided by 5. The number of C's is going to be about n divided by 5, right? So the average of this whole list of repeated tickets is going to be about, I'm going to see A about n over 5 times, B about n over 5 times, et cetera. If I average them, what am I going to get? I'm going to get something like A plus B plus C plus D plus E over 5. Approximately. Right? Each of them is going to occur about the same number of times in the n trials. Yes? I see them each about 1/5 of the time. Okay? All right. This number is the expected value of a draw from this box. The frequency interpretation is if I did the experiment over and over and over and over again, the probability that the average of the draws would differ from this number by more than a little bit gets really, really, really small. That is, the probability that the average of the draws is close to this number gets really, really big, approaches 100% as the number of draws gets big.